Welcome. In this particular video, we'll be finding areas of triangles once you're given the angle of the side and the angle of a triangle. Let's take a look at example 1. Find the area of the triangle shown below to the nearest tenth. So the first thing we want to do is to determine what information we're given. So notice here, so far we already know the measure of angle A is equal to 17 degrees. We also happen to know that the measure of angle C is equal to 69 degrees. And after we start labeling the sides, we know that the side across from angle A is lowercase a, the side across from angle B is lowercase b, and the side across from angle C is lowercase c. So we can also say that we have the information for B. Okay, so B is equal to 14 inches in length. Now, since we're trying to find the area, there are 3 different ways that we can find the area. We can actually use our basic formula, area equals 1/2 times the base times the height. We can also use Heron's formula, which is the square root of S times S minus A times S minus B times S minus C, where S is simply equal to A plus B plus C divided by 2. Or we can use the formula based on the law of sines, area equals 1/2 of A times B times sine of C, or any of the equivalent statements. So you could actually have area is equal to 1/2 times A times C times the sine of B, or area is equal to 1/2 times B times C times the sine of A. So based on this information, it seems that we cannot use the first one because we are not given the height, which happens to be perpendicular to the base. We don't have that information. We could possibly use Heron's formula, but we would need to figure out the measures of the 3 sides. Or here we can say, well, maybe if we can have the measures of 2 consecutive sides, okay, or 2 sides, and an angle included in between, we can possibly do that. So in this case, what we're going to do, since we actually know the measure of angle A, the measure of angle C, and the measure for the length B, we can try to use the law of sines in order to figure out the missing information, in order to figure out what is the value for C here. Okay, because if we're given C, then we can say, well, we have this side, then we have the measure of that particular angle and another side. So by the law of sines, we have the following. We have that sine of B over B is equal to sine of C over C. Now, after we substituted the information here, we know that we have sine of B. But what is B? Well, in order for us to figure out B, we know that the sum of interior angles in a triangle is 180. So we can say, well, we have 17 plus 69 plus, let's call it x for now, is equal to 180. So in other words, we have 86 plus x is equal to 180. And once we subtract the 86 from both sides of the equation, we can say, well, here we have that x is equal to 94. So that implies that the measure of angle B is equal to 94 degrees. So that gives us enough information so we can come back up here and say that we have sine of 94 degrees over 14 is equal to sine of 69 degrees over C, which we said was unknown. Now at this stage, what we're going to do is to cross multiply, since we're given the proportion. So we have 14 times sine of 69 degrees is equal to sine of 94 degrees times C. So solving for C, we need to divide by sine of 94 degrees on both sides of the equation. And we get that C is equal to 14 times sine of 69 degrees divided by sine of 94 degrees. So it will be good to get an approximation. Now, for us to get an approximation, we can use the technology. So in my case, I'm going to use the TI Inspire. And let's make sure that our Inspire is in degree mode. Now notice here the mode is in degree already, so I can go ahead and type in the following. 14 times sine, in this case of 69 degrees, divided by sine of 94 degrees. And I'm going to go ahead and hit Control Enter so we can get an approximation. Now, since we're going to round to the nearest tenth, I take a look here at the digit in the tenths position, and then immediately after that I pay attention to the digit to the right of that particular digit. And I see that this digit is 0, so I'm going to round this to 13.1. So going back to my notebook, I'm going to say that C is about 13.1. So that's good. Now we have enough information so we can apply our formula. Now, since we have the value for C, which we said was about 13.1 inches, what we're going to do, we're going to use this side, the included angle, and this other side. So we're going to be using sides B and C, and we're going to be using the measure of angle A, which is 17 degrees. So since we're using B and C, I'm going to be using this particular formula. So I can say, well, area is equal to 1/2 times BC times the sine of A. So substituting information, we have that this is equal to 1/2 times 14 times approximately 13.1 times sine of angle A, which we said was at 17 degrees. So let's go ahead and get an approximate answer for the area. To do that, again, we're going to use Inspire. So we're going to type in the information. So we have 1/2 times 14 times 13.1 times sine, in this case of 17 degrees. Let's close parentheses and let's hit Control Enter. And we get, roughly speaking, after we round this particular value to the nearest tenth, we get that the area is about 26.8. And let's pay close attention to the unit. So we can say that the area is about 26.8, and in this case we were dealing with inches. So area is always in units square, so this is about 26.8 inches square. And that's the area of this particular triangle. So let's see one more example here. Example 2, find the area of the triangle shown below to the nearest tenth. Okay, so let's go ahead and see what information we have. We happen to know the measure of angle C here is 21 degrees. We also happen to know that the measure of angle B is equal to 143 degrees. With that information, we can even find out what is the measure of angle A already. How do we do that? Well, let's use the fact that those angles are interior angles in a triangle, so their sum is equal to 180 degrees. So we can say, well, we have 21 plus 143 plus, let me call it x for now, that is equal to 180. So we have 21 plus 143 gives us 164, plus x is equal to 180. Subtracting here 164 from both sides, we get that x is equal to 16. So this particular measure is 16 degrees. So the measure of angle A is equal to 16 degrees. Now, labeling the sides across from the angles, notice that this will be side lowercase a, this one will be side lowercase b, and this one will be side lowercase c. We can also realize that A is equal to 7. Okay, we don't know what B and C are, So we're going to try to figure out at least one of those values. In this particular case, it will be great if we can just determine which side we want to use, so we can use a special area formula. Now, since we're already given A, we can either find out the value for B or for C. And in this case, I'm going to go ahead and find the value for B. Okay, so in order to do that, let's apply the law of sines. So by the law of sines, we have the following. We have that sine of angle A over A is equal to sine of angle B over B. After we substitute in the information that we know, we have sine of 16 degrees over 7 is equal to sine of 143 degrees over B. At this stage, what we're going to do is to cross multiply. So we get that 7 times sine of 143 degrees is equal to sine of 16 degrees times B. So let's go ahead and divide both sides by sine of 16 degrees. And this cancels out because that gives you 1, and 1 times B is just equal to B. So we get that B is equal to 7 times sine of 143 degrees divided by sine of 16 degrees. Now that is the exact value. So let's get an approximation to the nearest tenth. To get that particular approximation, let's use the technology. So using my Inspire, I'm going to type in 7 times sine, in this case of 143 degrees, and I'm going to divide that by sine, in this case of 16 degrees. Close the parenthesis and let's go ahead and hit a Control Enter. So roughly speaking, after we round to the nearest tenth, we can say, well, this is about 15.3 units. So let's go back to this one and we can say, okay, B is about 15.3, and in this case our units are miles. So miles. So we can return back to the diagram and we can say, okay, that's 15.3 miles, roughly speaking. Now notice that since we have two sides and the angle included between those two sides, we can actually apply the special formula for the area using sine. So we can say, well, here I'm going to use side A and side B. So I'm going to say, well, my area then is equal to 1/2 times A times B times sine of angle C. And after we substitute in the information, we get that this is A equals 1/2 times A, which we said was 7 units, times B, which we found it to be about 15.3 units, times sine of angle C, where C actually measured 21 degrees. Now, let's go ahead and get an approximation for that. Now, to get the approximation, again, we're going to be using the technology. So we get 1/2 times, in this case, 7 times your B, which we said was about 15.3, times sine. And in this case, we're using sine of 21 degrees. So let's go ahead and hit Control Enter. And we get that that's roughly speaking 19.2 after we round to the nearest tenth. Okay, so that's about 19.2 square units. So writing that information down, we have that the area is about 19.2 square units. In this case, our units were miles, so we can say that this is miles square. So to conclude, this particular video was all about finding the areas of triangles once you were given an angle, a side, and another angle. Thank you for watching, and have a wonderful day.